As a testament to the incredible marketing by the meat and dairy industry, the United States and now Europe and Asia even is walking through their day muttering the mantra, protein, protein, gotta have protein. So now we have protein bars, we have protein shakes, and we are overwhelmed, we are consumed, we are obsessed with getting protein. Well, what is protein and how much do we need, and are we getting adequate amounts? Okay, protein is basically a group of molecules called amino acids. Amino acids are produced by plants. They make these amino acids and they string them together. And when they're strung together, they become proteins. And there are little proteins and there are large proteins. Proteins are used in nature, in biology, for everything from enzymes to structure. They combine with carbohydrates to become antennae on cells and messengers. And proteins are just used very widely, and so they're essential to life. And that's what they are. So we definitely need to get some. But what do we really need? What we really need are its amino acid constituents, because we cannot ingest a foreign protein and use it. It's a foreign substance. As a matter of fact, if you took a protein from whatever your favorite protein source is and injected it into your blood, you'd probably die. Okay? You cannot use a foreign protein. What you must do is put it into your mouth, chew it, salivate, swallow it, break it down into its amino acids and absorb those amino acids. Those amino acids are then carried in the bloodstream, and as cells need them, they will pick them up and they will use those amino acids to manufacture their own protein needs. Okay, so that's what a protein is, that's why we need them, and then we can make, once we've absorbed those amino acids and they're in the cells, we can now use them to make enzymes, to make structure, to combine with carbohydrates to form antennae on the outsides of our cells, on the membranes, etc. So, how much do we need? Well, if we're going to find out how much we need, let's look at the time in our lives when our protein needs are maximum. And that's during infancy. Okay, and that happens to be true of all mammals. Protein needs are maximum during that time because the body of an infant needs to double and even triple in order to achieve viability. Okay? Otherwise, in the state of infancy, most mammals are helpless or close to helpless. So, how much do we need? Well, we can just simply look at the amount of protein in the milk of each mammalian species. Okay? Because nature already thought of this, amazingly enough. So, when we look at the protein content of different mammals, we'll find that we're on the bottom of the ladder. We only need 3 to 5% of our caloric intake to be protein. That's pretty easy. When you look at the amount of protein per calorie, in broccoli it's 35%, asparagus is 32%. Now dead cows, which people love to consume, only have 26%. Now even a potato has 8%. So the point is that it's not difficult. In fact, it's not impossible. I mean, it's not difficult at all to get your protein needs met. Which is why, in America, we, physicians, never, or rarely, I never have, and I don't know anyone that has, admit patients to a hospital with a diagnosis of marasmus or Kwashiorkor's disease. These are the two diseases that are associated with protein malnourishment. Where we do see these diseases occur is in places where there is famine, okay, such as in Africa. And that's where you'll see the child with the bloated belly. Okay? We don't see that here. We see bloated bellies from other causes. Okay, so we need very little. Of all the mammals, we need the least amount of amino acids. Now, remember that we mentioned that the amino acids are originally manufactured by the plants. So, by eating the plant, I can get amino acids in a more simple and pure form. It will require less work to assimilate them and to use them than it would if I ate a creature who already ate it and turned it into its protein. Okay? So now what about, well, yay, there's another mantra in America, and that mantra is If a little is good, then a lot is better. Well, this is not true in anything. It's not true in oxygen. You put a 100% oxygen mask on your face, and in about 2-3 weeks, you're going to start to have emphysema. Water is pretty important. Drink 5 or 6 gallons a day, and you will not be walking around too long. Okay? Carbohydrates, important. If you eat too much, you'll start wearing them. You wear them around your belly, breasts, buttocks, thighs, arms, and eventually your whole body until your ankles are hanging over your shoes. Okay, so that's carbs. Too much, clearly not good. Let's look at protein. Protein is broken down in the digestive tract into amino acids, as we said, and absorbed. When you get too much of this, the nitrogen must be excreted, and that's what kidneys are for. Okay, kidneys excrete nitrogen end products. Okay, and so once you overwhelm the ability of the kidneys to excrete that, and you're retaining this protein, and it's not able to be expelled through your feces, through your digestive tract, then the residue is collected in the lymphatic system. Now, the lymphatic system is a very slow-moving system that does not have a high oxygen content because it doesn't have its own blood supply. So here you have a foreign protein traveling very sluggishly in an environment with very low oxygen. This is a recipe for cancer. Thank you.